Alright, buckle up, folks. We're about to embark on a wild ride through the wacky world of mathematics. But don't worry, I promise to make this as painless and hilarious as possible. First up, let's talk about algebra. You know, that magical realm where letters and numbers dance together in a bizarre tango of equations. It's like trying to solve a Rubik's Cube blindfolded while riding a unicycle, confusing, yet strangely exhilarating. But fear not, my friends. With a little bit of patience and a whole lot of trial and error, you too can conquer the wild beast known as algebra. Just remember, when in doubt, guess and check. It's the mathlete's version of throwing spaghetti at the wall and seeing what sticks. Next, let's tackle geometry, or as I like to call it, the art of making shapes feel insecure about their angles. From triangles to circles to that weird trapezoid thingy, geometry is all about proving that even the most basic shapes can have a complex personality. And don't even get me started on proofs. Trying to prove that two triangles are congruent is like trying to convince your cat that it's time for a bath. Frustrating, futile, and probably best avoided altogether. Now, let's dive into some drawn formula pictures, shall we? Here's a little something I like to call the circle of confusion. Funny picture 1. And here's a visual representation of algebra. Funny picture 2. And finally, just for fun, here's a doodle of a triangle trying to do yoga. Funny picture 3. So there you have it, folks, a lighthearted romp through the quirky world of mathematics. Remember, math may be confusing at times, but it's also endlessly fascinating and full of surprises. So embrace the chaos, embrace the absurdity, and most importantly, embrace the joy of solving problems, one hilarious equation at a time. Embrace the chance to study now, as your success solely depends on you. Seize the opportunity, and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will. Title: Exploring Mathematical Concepts Through Real-World Examples. Introduction. Mathematics can often feel like an abstract concept, floating in the ether of theoretical equations and formulas. But fear not, intrepid learners. In this guide, we'll dive deep into the world of mathematics by exploring real-world examples that demonstrate the practical applications of algebra, geometry, calculus, and statistics. From solving equations to calculating areas and volumes, we'll tackle each topic head-on and provide exercises to reinforce your understanding. So grab your pencils and let's get started. Topic 1. Algebra. Example 1. Balancing a budget. Let's say you're planning a trip to the amusement park with your friends. You've set aside $200 for tickets, food, and souvenirs, but you want to make sure you don't overspend. To keep track of your expenses, you decide to create a budget using algebra. You start by setting up an equation to represent your budget. Total budget equals ticket cost plus food cost plus souvenir cost. Since you're not sure how much you'll spend on each item, you decide to use variables. Total budget equals T plus F plus S. Now, let's say tickets cost $50 each, food will cost $20 per person, and souvenirs are estimated to be $10 each. You can plug these values into your equation. Total budget equals 50 plus 20 number of friends plus 10 number of friends. Now, let's say you have 4 friends joining you. You can substitute the number of friends into the equation. Total budget equals 50 plus 24 plus 10 4. Total budget equals 50 plus 80 plus 40. Total budget equals $170. Exercise 1. Solve the following equation for x. 3x plus 5 equals 17. Explanation. To solve for x, we need to isolate the variable. First, we subtract 5 from both sides to get 3x equals 12. Then, we divide both sides by 3 to solve for x. X equals 4. Topic 2. Geometry. Example 2. Calculating area. Imagine you're a farmer planning to build a rectangular fence to enclose a garden. You want to maximize the area of the garden while using a limited amount of fencing material. To determine the dimensions of the garden that will yield the maximum area, you turn to geometry. You know that the area of a rectangle is given by the formula. Area equals length times width. Let's say you have 100 feet of fencing material to work with. You want to find the dimensions of the rectangle that will maximize the area. You start by setting up an equation to represent the perimeter of the rectangle, since the perimeter must equal the amount of fencing material available. Perimeter equals 2 length plus 2 width equals 100. Now, you need to solve this equation for one of the variables, so you can substitute it into the area formula. Let's solve for length. 2 length plus 2 width equals 102. Length equals 102 width. Length equals 50 width. Now, you can substitute the expression for length into the area formula. Area equals 50 width times width to find the dimensions that maximize the area. You can use calculus to find the critical points of the function. Exercise 2. Find the area of a triangle with a base of 10 meters and a height of 8 meters. Explanation. The formula for the area of a triangle is area equals a half times base times height, substituting the given values. Area equals a half times 10 times 8 equals 40 square meters. Topic 3. Calculus example 3. Maximizing profit. Imagine you own a bakery, and you're trying to maximize your profit by determining the optimal price to charge for your cupcakes. You know that the demand for cupcakes is inversely proportional to the price. In other words, as the price goes up, the demand goes down. To find the optimal price, you turn to calculus. You start by setting up a demand function, dp, where p represents the price of the cupcakes. Let's say your demand function is dp equals 102p. This function represents the number of cupcakes you can sell at a given price. The total revenue, R, can be calculated by multiplying the price by the demand. Rp equals P times dP. Now, to maximize profit, you need to find the price that maximizes revenue. This is done by finding the critical points of the revenue function using calculus. Exercise 3. Find the derivative of the function fx equals 3x 6x plus 2. Explanation. To find the derivative of the function, we use the power rule, which states that the derivative of xn is nxn1. Applying this rule to each term, f'(x) equals 23x21, 61x11 plus 0 f'(x) equals 6x6. Topic 4. Statistics example 4. Analyzing data. Imagine you're a researcher studying the relationship between hours of study and exam scores. You collect data from 50 students and want to determine if there's a correlation between the two variables. To analyze the data, you turn to statistics. You start by calculating the correlation coefficient, R, which measures the strength and direction of the relationship between two variables. You use the following formula to calculate R. R equals pounds xxy3 pounds xx2 pounds y3 2, where pounds represents the sum of x and y are the variables, hours of study and exam scores. X and 3 are the means of x and y, respectively. Once you've calculated R, you can interpret its value to determine the strength and direction of the correlation. Exercise 4. Calculate the mean, median, and mode of the following dataset: 12, 18, 20, 25, 30, 35, 35, 40, 42, 45. Explanation. To find the mean, add up all the numbers and divide by the total count. Mean equals 12 plus 18 plus 20 plus 25 plus 30 plus 35 plus 35 plus 40 plus 42 plus 45. 10 equals 312. 10 equals 31.2. Define the median. Arrange the numbers in ascending order and find the middle value. Median equals 32.5. To find the mode, identify the number that appears most frequently. Mode equals 35. Conclusion. And there you have it, real-world examples that demonstrate the practical applications of algebra, geometry, calculus, and statistics. By applying mathematical concepts to everyday scenarios, we can better understand their significance and relevance in our lives. So keep exploring, keep learning, and remember, math is everywhere, you just have to know where to look. Of course, before we delve into the exciting world of mathematics, let's take a moment to talk about the importance of community engagement on digital platforms like YouTube. When you come across helpful and informative content like this video, showing your support by liking, sharing, and commenting can make a big difference. Liking the video not only lets the creator know that you found their content valuable, but it also helps boost the video's visibility to a wider audience. Sharing the video with your friends, family, and followers spreads the knowledge and inspiration even further, reaching more people who could benefit from the information provided. Plus, sharing is caring, right? And let's not forget about commenting. Leaving a comment on the video not only fosters engagement within the community, but also provides valuable feedback to the creator. Whether you have questions, suggestions, or just want to share your own experiences related to the topic, your comments contribute to a vibrant and supportive online community. Lastly, if you want to stay updated on future content and continue supporting the creator's work, consider subscribing to their YouTube channel. By subscribing, you'll be notified whenever new videos are posted, ensuring that you never miss out on the latest insights and inspiration. So, let's show our support for valuable content creators by liking, sharing, and commenting on their videos. And don't forget to hit that subscribe button to stay connected with the community. Together, we can help foster a positive and collaborative online environment where knowledge is shared and appreciated by all. Now, let's dive into the fascinating world of mathematics.